your 16-bit, your 32, 64, etc., are affecting amplitude. Yeah. So these binary numbers then are stored on the recording medium, as a modulated square wave recorded at maximum level. Medium. Like that. So these are modulated square waves recorded at maximum level. And the type of modulation which is used to digitalize analog sound is known as pulse code modulation, PCM. Okay, let's finish this and then go straight to our place. And I also need to upload this material as you requested while you are here, before you leave here, so that you can go to Funda, check all this stuff. Now, this is the process simplified graphically here, like A, B, C, the numbers, and then the opposite is true when it comes to playback, right? They are read from the recording medium, that is the binary numbers. And the DA converter translates the numbers back into an analog signal, the continuous one, the electrical one, right? Made of voltage stabs, and an anti-imaging is used at the output. Okay, it's a smoothing filter. Because remember that was broken up that, and make it continuous again. Which is a low pass or smoothing filter reconstruction. And then it results in the original analog signal. Because we don't want the pitch to change when we play back. We want to play back what we capture. Young Todd.
Yes.
DA conversion. That's binaries, all your bytes there converted. Converted to voltage stabs like this, and this is the output after the filter. Going back to your sine wave. Bit depth. So the strings of binary numbers measured thousands of times a second is called binary waves. Okay? So the longer the bit depth of these measurements, the less noise is present on the recording. More specifically, for each bit added to a word, noise is decreased by around 6 decibels. Meaning, as I said, your bit depth affects amplitude. So there is some low-level noise which is created in digital recording. But then the bit depth, and especially making sure that it's the same number of samples per cycle, ensures that you get rid of that low-level noise. And again, this is also supported by the plugin that we use in mastering, known as the Data plugin. Okay? Meaning you are applying intentional noise to mask these digital errors.
Okay.
All those jittering samples. Sampling rate, also called sampling frequency. This is the rate at which the AD converter samples the analog signal. Yeah? So as an example, a sampling rate of 48,000 means that 48,000 samples are recorded per second when you digitize. Yeah? Remember, the highest input was 20, but then you are converting. The converter will then say, I want to use 96,000. You know? So the higher the sampling rate, the wider the frequency response of the recording. And that's the reason why when we do our recording, we just go for the highest sampling rate. We are worried about the frequency response. That's the main thing.